Okay, so like I said, I'm going to be completing one of these examples here. I haven't decided which one yet. I'm going to decide that in the next 4 seconds here. Um, we'll go with number. We'll go with number A. We'll go with letter A. So let's rewrite this one. First of all, I want to rewrite this as a matrix because I know how to pick and choose which numbers, but I want to make sure that I rewrite all the numbers accurately. So I'm going to rewrite this up here as 1, -2, -11, and then down here is -3, 3, 12. And we'll augment that one. That was a really bad augment. So we'll re-augment that one. Okay. So we know that x is equal to dx over d, right? We found that in the last video. We know that y is equal to dy over d. So we know that we're going to have d as the denominator in both of these, so let's just find that. Let's find the matrix D. So the matrix D is just going to be the coefficient matrix. So we'll take the coefficients and make a bigger fraction here. And actually I'm going to rewrite this just as the determinant of the matrix so that we don't get confused. But we'll have the determinant of the matrix down here and the determinant of the matrix down here. These are both going to be the coefficient matrices, or these are both going to be the coefficient matrix, so we'll have 1, -2, right? And then -3 and 3. And same thing with this one, coefficient matrix didn't change. dx, remember dx is going to be the matrix we obtain when we replace the column that's associated with the x's, which is this column, the A column, right? This is A, B, C, and this is 1, 2. So we know that we're going to replace the A column with the C column. So we're going to move this over here, and we're just going to rewrite it as it would be. So we've got -11, -2, 12. So sorry, 12 and then 3, because we move the column over, we don't just push it over. So C, like literally, you could slide it up and place it over top of A, and that's what the matrix would look like, and that's what we have here. And so for dy, it's the same thing, but we replace the coefficients corresponding with the y, so that's the B column. So we're going to replace the B column with the C column, and our matrix then is going to look just like this. So we'll have 1, -11, -3, and 12. Once again, that's 1, -11, -3, 12. If you can't read that, it's getting kind of small. But we know that these need to be the determinants, and our fraction is going to end up being a determinant over a determinant. And so to calculate our determinants, we're going to multiply across and then subtract, multiplying across the other way. So on top here, we'll have -11 times 33, or times 3, minus 12 times -2. On the bottom, we'll have 1 times 3 minus -2 times -3. And I like using parentheses so that we don't mix up our negative signs, because this is going to end up being a lot of negatives. And then dx or dy down here, the determinant of this matrix ends up being 1 times 12 minus -3, -11. And the last determinant again will match this one. So 1 times 3 minus -2 times -3. And from here, it's just simple calculations. So far, this hasn't been anything too challenging. It's just a process to follow and making sure you do all of it correctly. So we'll simplify this down. -3 or negative 11 times 3 is negative 33 minus negative 24. That'll give us negative 33 plus 24 is 9, I believe. Negative 9. Yeah, negative 9. And then we got 1 times 3 is 3 minus positive 6. 3 minus positive 6 is negative 3. The numerator for solving for y, 1 times 12 is 12, minus negative 3 times negative 11 is positive 33. So 12 minus 33 is going to be negative 21. And the bottom is going to be the same denominator, negative 3. And so, as we can see, these are both easily divisible by 3. That's not always the case. In this case it is, though. And so we know that x, the simplified version of x would be 3, because negative 9 divided by negative 3 is 3. And the simplified version of y, which is over here, negative 21 divided by negative 3 is 7. So our answer would be 3, 7 is our solution to this equation, which we found using Cramer's rule and determinants, and matrices, and all that good stuff. So why don't y'all try example B on your own? We'll talk about it in class. And yeah, thanks for tuning in.